So for the past model, we had seen that an exponential function looked something like this. The initial value multiplying the growth factor raised to an x, where a and b were any numbers. We're modifying slightly this function because sometimes it's easier to look at it in this way. So instead of the b, we're putting 1 plus r. I'm saying that the b is not going to be equivalent to 1 plus r, where the r is just the rate of growth decrease. R is usually going to be given as a percentage value. Okay, let's look at two easy examples. So example number 1. Find the rate of growth in the following function. So you have this. It is really easy to see that this number is the initial value. It's the one we call the a. The growth factor, the b, is 1.35 because the function grows from one value to the other by multiplying by 1.35. So first value is going to be 3, next value is going to be 3 times 1.35. After that is whatever we have obtained before times 1.35 and so on. But the growth rate, just the r, remember that the r is 1, the b is 1 plus r. The r is just going to be what is in excess of 1. So what is past the 1, in this case is 1.35 minus 1, the excess is 0.35. That's the r. The growth rate is 0.35, and usually we write it as a percentage. In this case it's going to be 35%. Okay, example number 2. In the year 2005, the population of a certain city was 1.1 million people and has since grown by 2% each year. Counting from the year 2005, so starting to count from there, what is an equation that models the population growth? Well, we're told that the initial value is 1.1 million people, and then we're given this percentage, which means that we're given the r, the rate of growth. But remember that percentages are not numbers, and what we put in the equation has to be a number. So you have to express the 2% as a number. That means 0.02. And now the growth factor is then going to be like the thing you put here. The b is 1 plus that. This is 1 plus 0.02, 1.02. And the function is finally, we'll just have to assemble all the pieces. 1.1, initial value, then the full growth factor raised to the variable. In this case I'm changing the y for p to mean population and the t to mean the time, but it's just basically the same thing.